Alright, so today we're going to be looking at the volume and surface area of a bunch of different geometric shapes, and the one we are starting off with is a prism. So we see a bunch of examples of prisms here. The big thing that makes something a prism is that we have really two bases, one on top and one on the bottom, that are the exact same shape, and they are connected with rectangles. For the volume of a prism, we just need to do the base area times the height. In the notes here it says area of cross section. That really is the same thing as the base area. We could slice the prism at any point and it would still be the same shape as the base. So that's base area times height. That's all the formula is. So right there we've got base area times height. For surface area, really none of the surface areas are going to be in the formula packet. There'll be parts that are, but there'll also be parts that aren't, and the reason why it's not really in the formula packet in the same way the volume formulas will be is because the surface area is going to be different depending on the context. Like sometimes if we're finding the surface area of a rectangular prism, it'll be representing a shopping bag that doesn't have a closed top, but sometimes it'll be like a enclosed box that does have a top. So it's going to be different depending on the context. But if we're doing a just closed rectangular prism, for example, or closed any shape really, it'll be 2 times the base area plus the side areas, which will all be rectangles. So for example, if we're doing a rectangular prism, maybe this one up here, we've got 2 base areas and then our side areas. And a note we have here that the rectangular sides are not always the same. They would be if it's a square or a regular polygon for the base, but we see here we have one short side and one long side. So for our base, so our side areas, we'd have like 2 that are connect with the smaller sides, and we'll have 2 that connect with the longer sides. And if it wasn't a rectangular prism, we might have more of these side areas, but for a standard rectangular prism that's closed on all sides, we'd have 2 base areas and then add up all the sides. But again, it's going to be dependent on the context to see whether or not we need to add like both bases or just one or any other combination. All right, so cylinders, that is going to be really similar to a prism. It just has a circular base. So we're still really working with base area times height. It's just that the base area now is a circle. So this right here, that's the area of a circle. So base area. And then we're still multiplying it by height. And for surface area of a cylinder, similarly, it's not going to be in the formula packet completely, but what you will get is parts of it. So you'll get the area of a curved surface of a cylinder, so that would be like this part here. When we unwrap a cylinder, it will be a rectangle and then 2 circles. And the curved surface is going to be 2 pi r, which is the circumference of the circle that we're working with, of the base, and then multiplied by the height. So this right there, 2 pi r, that is the base circumference. And then multiplied by the height of the cylinder. And then we can get the Other parts of the surface area will just be the circles that are the bases. So pi r squared would get us the area of those. And so similarly, you'll need to kind of connect the pieces yourself. It won't be writing this all out in the formula packet. You'll have to find the curved surface and the area of a circle separately, but you're going to add up 2 times, or the base area, which again would be 2 circles, plus the curved surface, which when we unroll it is a rectangle. And again, sometimes depending on the context, we might just have one base area. For example, a cup that doesn't have a lid would just have one circle and the curved surface. So we'll pay attention to all of that. All right. And then this next page is going to be pyramids and cones. So just like how prisms and cylinders share a lot of similarities in that it's base area times height, it's going to be similar for pyramids and cones. So those formulas are really connected. So pyramids are shapes that only have one base and then all of the sides meet at a single point. So the volume of a pyramid is going to be connected to a volume of a prism. We're having base area times height again. Only this time we're multiplying it by 1/3. And for surface area, once again, not in the formula packet, we have to piece it together ourselves, but for each of these prisms, we have some shape at the bottom and then a bunch of triangles. So we're going to have to add up the base area and the triangular sides. And again, the triangular sides are not always the same dimensions because the base might not have equal sides. So for example, if we had a pyramid that was something like this, where we had a flat rectangle with or a long rectangle for our base, we'd have our base area would be just that rectangle, and then the triangular sides, we'd have 2 that are bigger triangles and then 2 that are smaller triangles. So it looks something like we'd have 2 of these and then 2 of these. All right, so for cones are very similar to pyramids. We've got base area times height times 1/3 again, only our base area is now a circle, so we've got pi r squared representing the base area. We have our height, and then again we're multiplying it by 1/3. We'll do some examples below that will show us using these. And then surface area, again, the pieces are in our formula packet, but not the whole thing. The area, or so when we unfold a cone, we end up with a circle. So unfolded, we have a circle, and then we have it, this part becomes that's not ideal, a sector. So it'd be like this right here. So the area of a circle will be part of what we need to add. So we're going to add our base area. That is just this, pi r squared, it's a circle. And then curved surface. And that curved surface is going to be a sector where the sector length is the circumference of the circle. And the way that we get that, so this part right here, the area of that is going to be pi r L, well, where L is the slant height. So L would be that distance right there, because that slant height connects to the radius of the circle of the sector that we're working with. So not the radius down below, but the radius of our curved surface is part of a different sized circle. All right. So another common thing that we will be asked to do this unit is finding the dimension of lengths within a solid. Often they're called a transversal. It's going through. And when we see this picture down here, we can kind of imagine, I'll show you all in class with a clear solid with a pipe cleaner running through it, but imagine there's a pipe cleaner running through from one of the farthest corners to the next one here. To do this, you will often need to identify triangles, which are often going to be right triangles, to figure out all of the information we need. So, for example here, if we take a look at the transversal we got right here, we've got a diagonal running through our entire shape, and then it forms a right triangle here where this right here would be one leg, and then this right here would be another leg, and so we've got a right triangle. So if we build what we've got here, let's see, we've got the diagonal, which is what we want. We have this leg, and we have this leg here. We know this height will be 6 because it's the same height all the way around. But then what we're trying to find is red, but we don't have blue yet because blue is also a diagonal. It's a diagonal going through the base here. So if we check out this rectangle here, that would be this, where we have a rectangle with side lengths of 5 and 4, and blue is cutting across that. So in order to figure out what's going on with the length we actually want, we're going to need to do some work to figure out what all the side lengths of that triangle are. So we'll get blue here by doing Pythagorean theorem. So we have, we'll call this x. So 4 squared plus 5 squared equals x squared. So we're going to end up with 16 plus 25 equals x squared. And then, let's see, 16 plus 25, that will give us 41 equals x squared. And then we square root each side. And for here, since I'm in the middle of a problem, I'm just going to keep it as the exact answer of root 41 and label this blue side as root 41. So then when I go to try to find the length that I want, I'll label this with some letters. So we have D here, F is here, and what is that? That is B here. If I'm trying to find length DF now, we also have a right triangle, so DF squared will equal 6 squared plus root 41 squared. So now when I do root 41 squared, it just turns back into 41. Okay, but we're going to need some calculating over here. So let us see. Okay, there we go. We have 6 squared plus root 41 squared, which really I know is just going to be 41. And we get 77, and then the square root of 77 is equal to 8.77 if we're rounding to 3 sig figs. So the length DF equals 8.77, or really it's approximately because we rounded. All right, So there we go for that one. And then back to just some more simple examples of using the volume and surface area formulas. So if we have this triangular prism and we want to find the volume is going to be base area times height. So we have these right triangles and we have a base and we have a height. So we can do 1/2 base times height. So 1/2 times 4 times 6. So this is base area. And then times the height. So the height is 8. So that will equal we've got 1/2 and then times 4 times 6 times 8 equals 96. So this will be 96 centimeters cubed. All right, and so next for surface area, that is going to be, we have 2 bases here. So we have 2 times our base area, which will still be, it'll now be 2 times 1/2, 4 times 6, or really just 4 times 6, because the 2 and the 1/2 would cancel out. So that represents 2 of these. And then let's see, for our rectangles, we have a few different ones. So first, let's see if we have this rectangle here. That's going to be 4 by 8. So we have one 4 by 8 rectangle. And then if we look at our next one will be, we'll do this right here. That one is 6 by 8. So 6 by 8. And then the last one, there's one piece of information we don't have yet, because we have this is 8. So we need to figure out what is this length here in order to figure out what the dimensions of this last rectangle are. So to find that, I'm just going to do this off to the side. So what is the missing length we don't have? Well, we have a right triangle. Back to this right here. If we want that missing length, we'll just do 4 squared plus 6 squared and square root it. So our question mark here is really question mark squared. I'll give it a name. I'll call it x. So x squared is equal to 4 squared plus, that is 6, right? Yeah, 6 squared. All right, so let's see, we've got 4 squared plus 6 squared, and then we're gonna square root it, and we get 7.21. So x is equal to 7.21. When I end up doing my calculation, I will make sure to go up and grab that number. So the last one I need to add is 7.21 times 8, since those are the last dimensions. So as you can see, a bit more work just since we have to piece together all of the different sides. So, okay, I'm going to go ahead and just do 4 times 6 because I know my 2 and 1/2 will cancel out. And then I'm going to add that to 4 times 8. Then I'm going to add that to 6 times 8. And then I'm going to add that to this number here times 8. And we end up with 162 if we're rounding to 3 sig figs. So I'm going to just put that here. So surface area is approximately 162 centimeters squared. All right. Moving on to our cylinder down here. So volume again, nice and chill, just base area times height. So base area is a circle, so pi times 6 squared. And then our height is 18, so we'll multiply that by 18. And so let's see what we get. Pi times 6 squared times 18 will get us to 2040 if we're rounding to 3 sig figs. So 2040. Totally all good if you also write this out as 2036, that's fine. But it is okay to round to 3 sig figs like this. I know it can be a little scarier to round that much when we're like now 6 off from what it would be, but if we're not told anything else, 3 sig figs is always good, and I've got those 3. So it'll be this, and we're in volume. Oh, we're in inches now, so it'll be cubic inches. And then surface area here, if we go back and reference our formula, it's going to be the curved surface will be the circumference times height, and then we'll add that to the circle. So 2 pi r h plus pi r squared. So it'll be 2 pi r h plus, 2 pi r squared, because we have two circle bases here. 1, 2. All right, so that in this case is going to be 2 times pi. Our r is 6, our h is 18. That would be the rectangle once we unfold it. And then 2 pi times 6 squared. All right, so let's see. 2 pi times 6 times 18 plus 2 pi, and then we've got 6 squared. So there we go. We've got that being approximately 905 inches squared, since we're working with area. Area is square units. All right, last one here. Find the volume and surface area of this pyramid. So our volume is going to be that formula of 1/3 times base area times height. So for us, that's going to be 1/3. And then our base area is 8 times 5. And our height is 12. So let's see here. We've got 1/3 times 8 times 5 times 12 equals 160. So we've got 160 meters cubed. All right, surface area, we've got these triangles, and we have 2 types of triangles here. We have 2 of these, and we have 2 of these. All right, and we have the base of each of them, but we do not have the height. Since the height on this is like this right here, it is different, it is slanted, it is not just the height of the triangle. So we're going to have to figure that out by looking at, we're kind of building another triangle in here. That's a right triangle there. So really it's like, I'll use a different color. We have this triangle in here that is going to help us find the height of the blue triangle so we can then use it. So if we draw out this new purple triangle that we need to figure out what this length x is, because that's the height of our blue triangle, we need to figure out, okay, we know the height of that triangle is 12, and then this side right here, it could be really tempting to want to use 8 to get that, but really what this side is half of 5. So this right here will be 2.5 since it's half of 5. When we look in here, we've got x is our hypotenuse. We have this leg here, which is half of 5, and then we have 12. So we will set this one up. We have x squared equals 12 squared plus 2.5 squared. So we have 12 squared plus 2.5 squared equals here. So I'm going to keep this one in square root form. I'm going to call x square root of 150.25 using the exact value. The reason I'm keeping it in square root form is just because I still have quite a bit of calculations to do before I'm doing the final calculation of adding up all the areas. So since I don't want to go way back and have to go up to grab that value, I'll just keep it in square root exact form, so it'll be ready to go. Okay, so now we need to do the same thing to figure out what's the height of this red triangle here. And again, to do that, we have this new right triangle. I'll use green so we can see it a little better. Let's see. Okay. Oh no. It's okay. We don't need that anymore for that one. All right, green. So we'll be working with this triangle right here, where it's a right triangle. When we label all its dimensions. So the one we're trying to find, we'll call that y for now since we've already used x. Our height is still 12, and then this distance right here is half of 8, so it is 4. So putting this all together, we'll have y squared equals 12 squared plus 4 squared, so 12 squared plus 4 squared. So y is going to be the square root of 160. Again, I'm just keeping it like that because I don't have to go digging for my exact value in my calculator. Okay, now we've got the information that we need to do our surface area. So surface area, we got to add up first our base. So our base is just a rectangle. It's 8 times 5. We only have one base, so we just add that once. And then we're going to have 2 blue triangles. That's this one right here, and then it's that one back there. So for this one, we'll do 2, and then we have to do 1/2 base times height. So those will end up canceling out, but I'll write it all out. So 2 times 1/2, 8 times, and then remember we're not using 12 for the height because 12 is not the height of this triangle. The height of that triangle is this right here, the hypotenuse of the purple triangle. So square root of 150.25. And then we also have 2 of our red triangles, so we'll add that to 2 times, and then again 1/2 base times height. So the base of that triangle is 5, and the height is what we found here for y, so root 160. All right, and now we're ready to go, ready to type this all in to get the surface area. Okay, so the base is 8 times 5. The blue triangles will be 2 times, I'll just do 0.5 times 8 times square root of 150.25 And then we also have plus 2 times 0.5 again, 1/2, times 5 times square root of 160. All right. The reason I used 0.5 instead of 1/2 there was just so I could avoid adding fractions, because fractions can sometimes get things sort of off track in our calculator if we don't do it right with parentheses. But here we go. Surface area will be approximately 201. And we're working meters, so meters squared for that one. So surface area can be a lot just because we have to do so much calculation to get all of the different pieces added up correctly, but we've got it there. All right, that is all.